Hello and welcome to the first of 3 sessions which are focused on developing subject knowledge all about fractions. Now we're going to focus today on the question, what is a fraction? Just looking purely at finding the answer to and understanding to that question. The intention for this training is that it's for anybody who's working directly with the pupils, so teachers, teaching assistants, classroom support, class cover supervisors, and senior leadership as well, anybody that would benefit from really having that in-depth knowledge. Now, I'll add a little bit here just to say that yes, there will be some information in here which might be perhaps aimed at classes a little bit older than the ones that you normally teach. Equally, there might be things here that you might think, oh well, that's for children who are in younger year groups, the year group I teach. But actually it's important that all of us have a really clear, defined understanding of what fractions are, the same subject knowledge, the same vocabulary, so that when we're teaching, we're able to ensure that future learning is there and we've got that basis understanding of how to illustrate, how to expose the structure of this particular area of maths. So I'm just going to begin by pointing out that this training was developed with the help of Sam, who's an assistant maths sub lead at West Yorkshire Maths Hub that we work very closely with, and with lots of information, with resources from the National Centre for Excellence in Teaching and Mathematics. Okay, I'm going to give you a bit of a reminder of the 5 big ideas for teaching for mastery. I want this to be a mantra. We need to get this really stuck in our head. Okay, the aim is for each of these things to consistently contribute towards every thought process in maths. We need to always be thinking about these things whenever we're planning maths, whenever when we're in teaching mode, when we're giving feedback, when we're thinking about how to support pupils, when we're thinking about interventions. These things should be at the front of our mind. There's a separate CPD session which you're welcome to look at if you're not sure, having a brief look through the 5 big ideas. So I'm not going to go into detail about these right now. Just a reminder of what they are, looking at the representation and structure of whatever the maths is, looking at the mathematical thinking and considering that, making sure we're really securing fluency, making sure we're using variation to support the learning and move learning on and help develop understanding, and obviously the coherence and the small steps running all the way through all of that happening all at once is what makes maths the most successful. So let's keep all those things in mind. Now during the sessions, you're going to see this space pop up every so often. Now obviously I'm hoping that everything will be stimulating and you'll be thoughtful about everything that happens in these sessions. Maybe you'll make notes, maybe you'll come back to it and recap later. But when you see this icon, it'd be a really good idea for you to write something down. Make a few notes about your thoughts as well. When we next get the chance to get together and when we come to do a live session looking back at this training, we're going to focus on those questions or those ideas where this little thinky face appears. So if you see this, do think to make some notes. And there he is again. Here's your first one to think about. Okay, I want you to consider before we start, what are your experiences of teaching fractions at lower fields, perhaps beyond, but we'd like to focus on our cohort and our context here. What difficulties did you find in teaching it? What were the barriers that you came up with? What are some of the difficulties that you found that children were facing with fractions? What were they struggling with? What were they finding it hard to get over? So have a bit of a think about it, pause the video and write a few notes. Great, I'm really looking forward to having a look through those things and discussing what difficulties you found, because actually really unpicking those things is absolutely essential to knowing what to look for and to helping you develop your own knowledge as well. Now, here's the national curriculum, and this is about fractions in Key Stage 1, and I'm interested to see what your opinion is of this. So I'm just going to highlight a couple of parts just here. It says that the principal focus for mathematics in Key Stage 1 is to ensure pupils develop confidence in mental fluency with whole numbers, counting and place value. So that indicates that fractions are secondary. It's vital that we address the whole number fluency, the counting, the place value fluency. Now there's also a bit further down here as well which does indicate as part of National Curriculum for Fractions in Key Stage 1, recognising writing fractions for a third, a quarter, 2 quarters, 3 quarters in context of length, shape, set of objects or quantity, and to write simple fractions of amount. So for example, half of 6 equals 3, recognise simple equivalents like 2 quarters is the same as 1/2. Both of these objectives fall into the Year 2 category. And I'm curious to I'd just like you to think about what your opinion is. Do you think it's right? Do you think there should be more fractions going on in Key Stage 2? Or do you actually think that, no, maybe there should be less fractions in Key Stage 2, let's focus on the whole number work and move on beyond that? It's worth thinking about. It's also worth mentioning at this point that, again, that not every part of this set of training videos will apply directly to your classroom. But it's essential that we all have that breadth of knowledge, making sure we know where the children have come from and where they're going. So even if a particular part seems too young or too old for your children, stick with it and develop your understanding of fractions right across the primary curriculum. Okay, so looking a bit more closely at these 3 sessions, this session we're going to concentrate on what a fraction can be and understanding the answer to that question, what is a fraction? Okay, in future sessions we're going to look at that part-whole relationship, which is absolutely essential in fractions, so we're going to look at that in detail, and then we're going to look at comparing fractions and bar modelling with fractions and how some of that kind of comes out in the children's understanding. Okay, so I've got Thinking Face again. This is a little task for you. In your little paper pack that you have for this set of training, you should find a list of the National Curriculum objectives. There are 29 bullet points from the National Curriculum. They are of course not in order. Feel free to decide how you want to do this, but what I want you to do is identify which year group they fit in. So you could cut them out and sort them into different year groups, or you could just pop the year group at the side, whichever you feel is easier. Have a go, complete the activity, reflect on the answer, discuss your choices with a colleague, find somebody in the corridor, or maybe do it with somebody in your year group perhaps. Were there any really difficult ones? Were there any that you left blank? Were there any you just weren't sure about? How easy or difficult was this task for you to do? Reflect on that and then bring your ideas with you to the next session, and I shall tell you the answers to which one's going which year group when we have that live session. Okay, so this is what we're going to focus on for a moment. We're going to focus on what is a fraction, what can it be? Okay, I want you to think about that question for a moment before continuing with the video. What is a fraction? What can a fraction be? What are the different elements of a fraction? What is your current understanding of what a fraction is? What is your current teaching answering this question? So there are 4 aspects of fractions that we can consider, and we're going to have a look at each of these in a little bit more detail in a moment, but for now we're just going to compare them to your thoughts from the previous slide and see if you've got any of these little bits coming up. So one particular aspect of a fraction could be as a number, as a measure, or in a linear sequence. Okay, so for example here, a representation of that, we've got a number line showing 0, 1 quarter, 2 quarter, 3 quarters, 4 quarters. 3 quarters is a number as it appears on a linear number line. We could call that a ruler and be measuring quarters of inches, for example, things like that. That's what we're kind of looking for. We've also got that amount. So that's one particular aspect. Another aspect is the part whole or the part many relationship. So these very, very common images, we've got the bar model showing 3 quarters or 3 out of 4 parts of the whole. And then below that, we've got the 4 counters with 3 red counters out of 4 counters altogether. So the first one, the bar model, showing the part whole relationship, how many parts out of the whole, and the counters there showing the part many relationship, the numbers of parts out of a whole number of items, the number of bits out of a whole number of items. I wonder if you thought about fractions as a division or as the quotient in a division. And Very simply, that's the idea that 3 wholes divided by 4, or 3/4, is the same thing. So 3/4 can be represented as 3 divided by 4. The fraction is the quotient, or if you like, the answer to the division. 3 divided by 4 is 3/4. Perhaps you thought of it as an operator, so as something we can actually use in calculation. 3/4 of a number, 3/4 of a whole number, 3/4 in this example, 3/4 multiplied by 8. 3/4 multiplied by 8, or 3/4 of 8. So we could use fractions there as an operator, as a multiplicand, or a multiplier, actually in a calculation. Now, as I say, we're going to look at these 4 areas in some detail just next now. But before we do, it's worth mentioning here that there can be a lot of overlap between these. It's not a specific set of discrete things. There's not 4 definitions of a fraction. These ideas just help us to remember the different things that a fraction could be, and also how it applies to wider mathematical areas. So that idea of it on a number line, bringing it as part of a number, thinking of it as its relationship to decimals and how that fits into the place value set, that kind of idea. As an operator, looking at its fractions of amounts and how we can use it in multiplying and dividing. All these different areas that we can actually relate fractions to. So let's have a look then at what a fraction is. So we're going to focus on these 3 areas just first. Okay, now some of this information here from the NCETM is based on research by Panzara and Philippou, who refer to fractions as a multifaceted construct, meaning it's lots of different perspectives. It's being part of a whole is needed to understand the other aspects and is believed to be the best understood by children. But this alone is not enough to achieve fluency in terms of their conceptual understanding. So just understanding the part of a whole element isn't enough for them to really have that fluent understanding of the concept of fractions. Part of a whole is associated with equivalence, which is a multiplicative idea, comparison, as well as additive fractions and addition of fractions. Equivalence is believed to be one of the most important mathematical ideas, so we're looking to think about equivalence in fractions. We can also consider that conceptual understanding can be measured by recognising equivalence and then comparing and ordering fractions, which leads us into understanding a fraction as a number or an amount in its own right. Finally, it's important eventually to understand the multiplicative element of a fraction, including how a fraction is the quotient in the division, and that starts to come up really when you get to year 6, really getting that deeper understanding, because that then leads to the understanding of fractions as decimals and percentages as well, and that will link to other areas of maths. So let's look at some of these bits in a bit more detail. So as a number in its own right, fractions as a number in their own right allow us simply to count in fractions. We can count in fractional steps, looking back at that example that we had from the table there, counting up in quarters. This idea of equivalence between fractions is hugely important as well, both for future application and the basis of conceptual understanding. It can also help us to lead to unitizing with fractions, which is central for adding and subtracting. Now, when we take a look at this idea of equivalence and comparison, the idea that 3/4 is greater than half because we can see where half appears on the number line. We know that 3/4 is a value. It doesn't have to be 3/4 of 12 things. It is a value of its own. It's a number of its own right, and as a value it is greater than 1/2. Looking at the idea that 2/3 is equal to 6/9, which then helps us with our understanding of the fractions. It helps us to work with ratio, it helps us to work with multiplying fractions, adding, subtracting fractions where we need to find those equivalences. So a really, really vital step, but it is very abstract. So we need to spend a lot of time looking at it on a number line, comparing fractions, both with physical resources as well as pictorially, is also essential in developing that understanding of a fraction compared to other fractions and as a number. We can use fractions as an operator, and it's this understanding of the part-whole relationship of a fraction, which is associated with almost all areas of fractions, and in essence with what a fraction is. In fact, we spend the whole second session looking at that part-whole relationship. And this idea that you've got three parts out of one whole, and that being represented here by the bar model. We can also then link this to operations. So for example, 3/4 of a set of marbles. So we've got the 3 out of 4 counters there, but we can also then look at the actual set of marbles and think, well, I've got 8 marbles, what's 3/4 of that? I'm going to divide it into 4 equal parts. 3 of those parts is 3/4 of the amount. And that operator is really important. Now, partitioning whole and fractional numbers is also an application of this aspect. So we might look at using part-whole models, for example, looking at how many different parts that would come together to make a whole, or even parts that might come together to make other fractions, and looking at that relationship between those things. This is also a great way to build up on some of the Roger Bird work we're doing. So, 3 things plus 4 things equals 10 things. So you could say that, 3 things plus 4 things equals 7 things. You could say 3 sevenths plus 4 sevenths is 7 sevenths. And then the relationship that 7 sevenths is the same as a whole. This is really important. Final idea is the idea of iteration. That might be a word or a concept that you're not quite so familiar with. So we're going to look at iteration in a little bit more detail. So iterating fractions. How can you tell that something is 1/5? How do you know? How do you know something's a fifth? In your pack, you'll see, I think at the bottom of the first page, I'm not sure, but you'll see somewhere there's a box with a fifth written in it. That fifth, that box, is part of a diagram. What I'd like you to do is to complete the diagram. I want you to draw the whole. So that box represents 1/5. I want you to draw the whole. Have a go, pause the video and see what you come up with. So what did you do? I'm imagining, hopefully, that you did something that looks a bit like this. 1/5 is 1/5 if we can copy it or iterate it. Iteration is simply copying something. If we iterate it 5 times, if we have 5 copies of a fifth, 1, 2, 3, 4, 5, we get to 1 whole. And hopefully your whole diagram kind of looks a bit like a bar model, something like this. And that's the idea of iteration, the idea that a fraction is made up of this repetition. Now we can also look at iteration from this perspective. So here's a problem. The blue circle represents 1/5 of class A. Inside the red circle is 1/6 of class B. How do you think you could solve this problem? How many children are in each class? Which class is bigger? Which class is smaller? Can you describe what you did using iteration as the idea, as the concept behind it? So of course you've got 1/5 of class A, that's 4 children, so you'd repeat those 4 children 5 times. 5 groups of those 4 children, and for the 1/6 of class B, you're looking at 6 groups of those 4 children. How many children altogether? And using that repetition 5 times for class A because it's in fifths, 6 times for class B because it's in sixth. That's the idea of iterating fractions and using that method to solve problems. So which class has more students in it? Of course it's class B, because class B has 6 lots of those 4 students, which is 24 students altogether. Class A has 5. How about this? So a quotient in division. To understand what this means, we need to understand a bit of the multiplicative relationship. So let's just take a little bit of a step back. When we're calculating, you might not know this, you might know this. Hopefully you will start to become familiar with this. We have specific names for each part of the equation to help us understand the different parts and help us understand the structure. So the quotient is the result of dividing one number by another. The diagram on the screen there shows you the dividend is what you're starting with, the divisor is what you're dividing by, what you're grouping it into, and the quotient is, let's call it the answer for the purposes of this. Now, understanding of a fraction as a quotient in division might only really come on later in the primary phase. We look at this in year 6. But it is important understanding to division and supporting the understanding of what division is. So if this example doesn't help you to see this, 3/4 is 3 divided by 4 is 3/4. Why do you think about 1 divided by 2? That's one whole thing shared into 2 pieces, which is equal to a half. And actually, right back in year 1, we think about what's 1 divided. We think about half. We think about having a circle and shading in half of it. We're looking at those things right back at the beginning of primary, and there's no reason at all. Obviously, I'm not expecting them necessarily to write out equations like this, but there's no reason at all for us to start to introduce that idea. Oh yes, we've got one whole circle, and we've divided it into 2 equal pieces, and we've got 1/2. Using that language helps to support that understanding and they can then bring that right the way through primary, so they've got that secure understanding before they get to really needing it when we come to needing to do, say, 3 divided by 4 in order to find a decimal equivalent. Now, to finish off this session, we're going to take a look at this problem. So Joe and Sarah are sharing this food. How would you make sure each person got their fair share? Can you answer that question? How are each of the different foods different in answering this question? Have a bit of a look, have a bit of a think about all the different things on the table. How do we make sure we get a fair share? Now, the principles underpinning the concept of fractions as being equal parts of a whole need to be introduced with concrete resources in a context that's meaningful to children. We need to show them something. When we're looking at this part-whole relationship, when we're looking at how fractions work, we need to show them a context that is meaningful to them. This is an enrich activity. It's called Fair Feast. It's a starting point. It is set in a familiar context of sharing food. It provides an opportunity to explore fractions in lots of different ways. The task involves finding fractional quantities of whole numbers as well as dividing a unit into equal pieces. The initial activity starts with sharing between 2 children, dividing by 2, essentially finding half of different wholes. So we've got different wholes. For example, the pizza is a whole, the apple is 1 whole. But the muffins, there are 4 muffins there that we're going to share. That's the whole, those 4 muffins. That plate is the whole. That plate of cherry tomatoes is the whole. But in fact, there are 8 cherry tomatoes there. Those 2 cartons of orange juice, they are the wholes. So we have different elements of the wholes. We're looking at fractions of shape. So we've got a circle there that's been cut up into 4 pieces. How many of those pieces, what does that represent? They represent quarters. How many of those quarters? How many of those pieces? You look at the apple, you've just got the 1 apple. That spherical object. You cut it in half, what are we going to get? We've got that fractions of shapes. We also have fractions of quantity, including in measured amounts. We've got the muffins, we need to share those between 2. We've got the 8 tomatoes, which need to be shared equally between 2. The orange cartons perhaps are easy because there's already 2 of them. We also have the pizza. If you think of that as a quantity, as an amount, we've got 4 slices of pizza. How much will each person get? When we think about that, one pizza shared between 2 children is 1 divided by 2. This results in half a pizza each. And look, now we've already got into that language of fractions as a quotient in division. So developing conceptual understanding of different wholes is a key concept. 1 whole might be the pizza, or it might be the bowl of tomatoes, or the plate of muffins, or the 1 apple. It could be a 2-dimensional shape. It could be anything. The activities themselves need to be practical, use real objects so that children have the opportunity to experience dividing these things into 2 parts, into halves, and then moving on to dividing things into 4 parts or quarters. The pizza can be shared between 2 people, each gets a half. Before moving on, it's worth highlighting this concrete understanding should be experienced right across the primary phase. When you're starting fractions, when you're looking at fractions, when you're recapping some information, when you're looking at adding, subtracting, multiplying, dividing fractions, get these physical things and do something, move them around. It is so important for that understanding. Now, just before we finish, what about this? Sam and Emma joined them before they started to eat. how much of each thing would each person get now? What about this? If we add the dessert in there, how much of that are each of the people or each of the friends going to get? So what if we divide it by 4 people? Of course, the pizza, each person gets a half. Conveniently, it's already split into those 4 equal pieces. 1 whole apple shared between 4 children is 1 divided by 4. So they get a quarter of the apple each. So if what about the tomatoes? If they're divided by between 2 children, between 4 children, what about 8 children? And just to finish off, I'd like to remind you that this training was supported by West Yorkshire Maths Hub and the NCETM. I'm really very thankful for you for listening and watching and taking part. Don't forget to have a little bit of a conversation, share your ideas, particularly those thoughtful, thinky faces slides with some colleagues, and we shall discuss them when we come to our next live session.